In this video, we'll discuss PYQs on eigenvalues. But before diving on them, we first introduce two powerful tricks that can significantly speed up your problem solving process. Let us start with the first one. It says sum of the eigenvalues is equal to trace of the corresponding matrix. Now, what is trace? Trace is simply sum of the diagonal elements. Therefore, it says that sum of eigenvalues of a matrix is sum of the diagonal elements of that matrix. Take for example this particular matrix. If you calculate its eigenvalues from the characteristic equation, you will get them as 6, 3 and 3. Now what is their sum? The sum is simply 12. Now note carefully, if you add the diagonal element of the matrix, you will be getting 12 as well. Now that is what this result is saying. Let us move to the next trick that says product of eigenvalues is equal to determinant of a matrix. Now note carefully, if you consider the same matrix having eigenvalues 6, 3 and 3, then product of the eigenvalues will be 54. If you calculate the determinant, you will be getting 54 as well. So empowered with this trick along with the last one, you will be able to punch through the PYQs effortlessly. So let us start solving PYQs on eigenvalues. The first sum from JAM 2022 that says the sum of the eigenvalues of the following square matrix is what? Now we have just seen sum of the eigenvalues mean just the trace of the matrix, or in other words sum of the diagonal elements. Now what is the sum of the diagonal elements here? It is 1 plus 5 plus 1, that means 7. So 7 is the correct answer. Next sum from JAM 2023, question number 35. For alpha beta belongs to R, where alpha naught is equal to beta, if minus 2 and 5 are the eigenvalues of the matrix M, a 2 by 2 matrix having entries 1 minus alpha, 1 plus beta, beta, alpha plus beta, and X column vector x1, x2 is an eigenvector of M associated to the eigenvalue minus 2, then which of the following four options are correct? First option is 2x1 plus x2 is equal to 0. Second, beta minus alpha is equal to 5. Third, alpha square minus beta square equal to 5. And the fourth one, x1 plus 3x2 is equal to 0. We'll start with those two tricks. The first one is saying that sum of the eigenvalues is equal to trace of the matrix. Now the sum of the eigenvalues means minus 2 plus 5, and that will be equal to trace of the matrix M, that means sum of the diagonal elements 1 minus alpha plus beta. So from the right hand side you can see minus alpha plus alpha will get cancelled, so you will be having 1 plus beta is equal to 3, that means beta will be equal to 2. Now from the second trick we know that product of the eigenvalues minus 2 times 5 will be equal to determinant of the matrix M. Now what will be the determinant of M? Note carefully, determinant of M will be equal to 1 minus alpha times alpha plus beta minus 1 plus beta times beta. Now we have already evaluated the value of beta to be 2. So let us put it here. So if we are putting it here, we are getting 1 minus alpha times alpha plus beta means 2 plus alpha minus 1 plus beta means 3, and beta is 2. Together they are giving you 6. So let us simplify this. You are getting in the next line 2 plus alpha minus 2 alpha minus alpha square minus 6. That means we are having 2 minus alpha square minus 6, that means minus of alpha square minus alpha minus 4. So from this we are having left hand side minus 10 is equal to minus alpha square minus alpha minus 4. That means when you are bringing everything on the left hand side, you will be getting alpha square plus alpha minus 6 equal to 0, and then you'll be getting alpha square plus 3 alpha minus 2 alpha minus 6 is equal to 0. That means alpha plus 3 times alpha minus 2 is equal to 0, from which you are having two values of alpha, alpha to be 2 and alpha to be minus 3. But note carefully that alpha cannot be 2, since it is given that alpha and beta have different values, and we have already evaluated beta to be 2. So definitely this is not possible. So the value of alpha is minus 3. So we have obtained alpha to be minus 3, beta to be 2. So now from this relations, just let us see how many options can we take care of. The first one, note carefully, let us come to option number B. What is beta minus alpha? Beta is 2, minus alpha means minus of minus 3, so beta minus alpha is 5 is correct. What about option C? What is alpha square minus beta square? Alpha square is minus 3 square, that means 9. Beta square is 2 square, so minus 4, so that will give you 5. So option C is correct as well. We have already obtained the value of alpha to be minus 3 and beta to be 2. Just by putting them here, we can write m clearly. So m is 1 minus alpha means 1 plus 3, 1 plus beta means 1 plus 2, 2, and alpha plus beta is minus 3 plus 2. So row wise we are having m as 4, 3, 2, minus 1. Now here it has been said that this x1, x2 is an eigenvector associated to minus 2. That means m times the eigenvector x1, x2 will be equal to corresponding eigenvalue minus 2 times that eigenvector. So now let us put all the values here and let us see what we are having. M row wise it is 4, 3, 2, minus 1 times x1, x2 is equal to minus 2x1 minus 2x2. So from the left hand side we are having 4x1 plus 3x2, 2x1 minus x2, and on the right we are having minus 2x1 minus 2x2. So when you are comparing the left hand side and right hand side, from the first rows we are having 4x1 plus 3x2 is equal to minus 2x1. So when you are bringing this side here, you will add it here. So you will be having 6x1 plus 3x2 is equal to 0. And similarly, from the next line, you will bring this on the left hand side. So you will be having 2x1 plus x2 is equal to 0. Now note carefully that 2x1 plus x2 is the first option. So option A is correct. What about option D? Suppose option D is true. That means x1 plus 3x2 is equal to 0. Then just multiply that with 2. So we will be having 2x1 plus 6x2 is equal to 0. Call it 1. Call it 2. So when you are considering 1 minus 2, when you are subtracting 2 from 1, note carefully what we are obtaining. Your 2x1 will get cancelled and you are left with 5x2 to be 0. That means x2 will be 0. Now when you will put this value of x2 here in the first equation, this part will be 0. So that means x1 will turn out to be 0 in this case. So x1 will be 0, x2 will be 0, will give the eigenvector x to be 0. But the eigenvector cannot be a 0 vector. So definitely our assumption that this relation is true is not valid. So definitely D cannot hold true. So the correct options are A, B and C. Next sum from JAM 2024, question number 37. Let M be a 2 by 2 square matrix given by alpha minus 6 minus 1 1. If the eigenvalues of M are beta and 4, then which of the following is or are correct? 4 options are given. First is alpha plus beta is equal to 1. Second, an eigenvector corresponding to beta is 2 1 transpose. That means column vector 2 1. Third, the rank of the matrix M is 2. And the fourth, the matrix M square plus M is invertible. Let us apply those two tricks. The first trick is saying that whenever you are adding the eigenvalue, that means 4 and beta, you are supposed to get trace of the matrix M, that means alpha plus 1. So from this we are getting alpha to be beta plus 3. Next, the second trick is saying whenever you are taking the product of the eigenvalues 4 and beta, you are supposed to get the determinant of M. Now what is the determinant of M? It is alpha minus 6, from which we are getting alpha to be 4 beta plus 6. Now by comparing 1 and 2, we can see beta plus 3 is equal to 4 beta plus 6. That means we are having 3 beta is equal to minus 3. That means beta is equal to minus 1. Now when you are putting that value of beta in equation 1, you will be having the value of alpha as minus 1 plus 3. That means 2. So we have obtained the value of beta as minus 1, alpha as 2. So when you are adding alpha plus beta, you are getting 1. So option A is correct. Let us now check option C, whether the rank of the matrix M is 2 or not. Now note carefully, rank of the matrix will be 2 if determinant of M will be non-zero. Now what is the determinant of M? If you calculate the determinant of M, you will simply use the second trick, which say the determinant of M is nothing other than product of the eigenvalues. That means determinant of M will be 4 times beta. The value of beta is minus 1, so minus 4. So we can see that the determinant of M is non-zero. So definitely the rank of the matrix M is 2. Let us now check whether D is correct or not. Here you have been asked to check whether the matrix M square plus M is invertible or not. Now note that this is equivalent to saying whether the matrix M square plus M has determinant 0 or not. If M square plus M has determinant 0, it will fail to be invertible. Otherwise, it will be invertible. So let us check what is the determinant of M square plus M. Now determinant of M square plus M can be written as the following way. We can take out M. So if we take out M, we can write the determinant of M times M plus identity. And now we can split it like this: determinant of M times determinant of M plus I. Now note carefully that beta is an eigenvalue. Since beta is an eigenvalue, so definitely determinant of M minus beta I will be 0. That is the definition of eigenvalue. That means if you put the value of beta, you will be getting determinant of M plus I is equal to 0. So that means this part will be 0. So this is equal to determinant of M, that means minus 4, times 0, that means equal to 0. So this matrix will fail to be invertible since this matrix has determinant 0. So D is incorrect. Now let us check whether option B is correct or not. So in option B, you are supposed to check whether this column vector is an eigenvector corresponding to beta or not. So when this will form an eigenvector of beta, if this equation is getting satisfied, only then you will be able to say that beta has an eigenvector 2 1 transpose. So let us check whether our left hand side is equal to right hand side. So what are we getting from the right hand side? From the right hand side, if you put the value of beta, that means minus 1, you will be getting the right hand side to be minus 2 minus 1. What are we getting from the left hand side? Let us put the value of m. What is m? We have already seen the value of alpha is equal to 2. So if we put 2 here, we'll be getting the value of m as 2, -6, -1, 1. Now what will happen if we multiply that with 2, 1? If we multiply with 2, 1, are we getting this? Let us check. If we multiply that with 2, 1, the first row will be 2 times 2 plus -6 times 1. That means 4 minus 6. Similarly, the second row will be -1 times 2 plus 1 times 1. That means -2 plus 1, which will be -2 minus 1. That means this one. So that means this relation holds true, and therefore we can say B is also a correct option. So definitely the correct options are A, B and C. D is incorrect.